So, anyway, we're going to have next, after this first session, presentations which go a bit more into details with specific pilots, which will give you a flavor of what really each project is about. But now we're happy to have with us Arndt-Peter Schulz. And Arndt-Peter Schulz is from Fraunhofer.
Yes.
Fraunhofer is one of the favorite partner of many European projects, I must say. Usually that's a name you find in most of the key large-scale projects in the last 20 years or so. They are also part of Confortage. So you are the happy winner of the third project, which just started right now, which is again a different focus, both clinically, but also technologically, as it's more technological focused project, I must say. So please, you have 10 minutes to tell us what you hope to achieve as you just start right now.
Absolutely right, thank you. I think we need our slides. I can see stage here, but now we all smile. Thank you. Yes, thank you very much. My name is Arndt-Peter Schulz from the Fraunhofer Institute in Lübeck, as well as the Trauma Hospital in Hamburg, and I'm talking about smart implants for life enrichment today. Where can I change the slides? Here we go. So, let me start with this. Thank you for the invitation. I am German, not French, so less emotional, more rational. For all of you who think about going for an application for funding like this, to bring you down to earth now, we spent about 850 emails, about 100 video conferences, and about 250,000 euros in personal cost before we even handed in our project. Fortunately, the German government was so nice to support us a bit in that. You can see the first slide here. That was from a meeting about 4 years ago when we all started with this project, which we have now begun on the 1st of January of this year. We spent about 11 countries at about 26 parties. I say about because 3 of our partners have split up into 2 partners or more, so that 26 partners is the current situation. It's quite German-centered. That is my fault because, you know, my network is mainly based in Germany, but the work packages themselves are quite evenly distributed in Europe. And what is it about? It is really a technological project. Don't worry, I don't get into the details of the technology. What we aim to do is to bring smart technology into the human body and giving this technology a real sense. We have a duration of 5 years and a budget of roughly 20 million euros, and the Swiss government helps out a bit more. It's basically the idea of the harmonization of smart technology of different applications, all based on one electronic platform. Let it be implants, but also externally worn devices. Also, what will keep all these technologies together is a unique software platform, let's say, a system that helps to make sense of these different technologies, bringing the information to the patient and to the health care providers, the doctors, the hospitals, the therapists, and so on. So in the core is a chip platform. Why do we do that? We have experience in this. Let's say in the core Hamburg area, we're working on projects like that beginning in about the late 90s in different stages and have at the end designed or created a project that has been implanted in about roughly 60, 70 patients, monitoring fracture healing, fracture monitoring. and then came to a stage where we saw that if we want to bring this technology to the broad public, we need bigger partners, we need specialists in the different fields, and so we said we have to expand from the core of Hamburg to the whole of Europe. So the idea in 2 nutshells, really. If we have a look first at the, at our aim, the elderly patient and the quality of life, then we have to see, or we have to assemble things that make up, the quality of life of elderly patients. So that's the stage we are at the moment. So we are looking at what is important. Is it participation? Is it quality of life? Is it independence? Is it information management? Is it self-esteem, involvement, or is it a bit of all of them? And then at the next step, we'll have a look which actual technology will help to achieve these goals, which then makes up the needs of our technology. And then we come to this technological core. We've got a chip platform that will be developed, that will be available by licensing or whatever, freely to the whole of Europe. So every manufacturer of electronic devices that are implanted in the human body or are worn in other sorts of medical technology, orthosis, wheelchairs, whatever you want, can make use of this chip platform, so they can interconnect with all other devices. We will develop several sorts of sensors and features that this chip platform can work with. We will have to have a look, and that's the establishment of needs first, which sensors and which features make sense and will be needed. We are targeting, in the first step, a few applications. It says here, I don't know if you can read it, should be all right, in the prosthesis of the hip or the knee or whatever, ligament sensors, osteosynthesis plates or nails. We also external devices like wearables, like crutches, orthosis. So that will be the applications that we target at the beginning. And the supporting infrastructure will be developed around that. So that at the end we have got something that A, makes sense, and B, companies can make a product out of it. So without a product, what are we at the end? We've had a nice research project and the world goes on. No, that's not our aim. We want to really give Europe a market, so that we are ourselves sustainable and have got a longevity. So the concept in nice pictures. I don't go into it too much. Just the rough technology. We'll gather information at the end of the day. We'll gather information of the hospital information systems, of the patients themselves via prams or whatever, and our newly developed implants. All this information goes into our software cloud, let's call it, and is processed there using data analytic methods and quite a lot of AI, which is, we think, very important. The whole system will work with an app, web-based interface, so wearables and implants transmit their information to the patient's mobile phones, iPads, whatever. The patient will have full control of the data that is gathered and the way it is processed, or to whomever this information is given out to. And the healthcare providers can fashion their treatment or the prophylactic measures or whatever to this information gathered. The project structure, you all are working in projects like this. I don't go into this very much, but in our SmILE project, we've got 8 working packages. Working package 7 ends basically in some working prototypes. I will have a look into that in the next slide. And then we have got the usual project management setup with committees, steering committees, patient committees, ethical committees, and so on and so on. That has all been set up now and is starting to work. So let's have a look briefly at the use cases. As I said, our smart medical devices technology requires the chip platform, and it requires the software platform, which is as important as well. But then we will, in the end, in the last 2 years of our project, have use cases that we will be trying out in patients, which will be orthosis, so external devices. 1 minute. I need to. Also in walking aids, we'll have technology that we'll be probably using in animal testing, which will be performed here in Spain, and osteosynthesis plates and bone, nail, and all the prosthetic and much more technological stuff will just be tested in laboratory research. It says 30 seconds here. Da. So the working principle as it works now is forces, for example, are transmitted in the human body, and if you've got an implant sitting there, then you can measure these forces, and you can transmit them somehow to the outer world. And if you then put that into a context, you can make sense of the data. So the future system will be something very fancy. We don't get into that too much. Last thing I would like to talk about is we are talking about the importance of artificial intelligence, and what does artificial intelligence need? It needs basic data that it can work with, that it can compute and make sense of it. So what we have to establish is, because we are a musculoskeletal research and development network, we need motion data. There is none freely available, so we will set up a large European database for motion data, and this data then can be used for artificial intelligence systems. So that's the contact information. Feel free, if you've got future projects you're interested in, always give us a shout. We are available for nearly everything. Thank you very much.
Thank you very much, Arndt-Peter.
Yes, I said just ask questions if you like, but I'm sorry, we'll have to do that in the coffee break.
Yeah. Let's try not to shorten too much the coffee break.